In this video, I'm going to explain the concept of Lhopital's rule in calculus. Lhopital's rule in calculus is a technique to evaluate the limits in the indeterminate form. There are many indeterminate forms, but we are going to focus only two indeterminate forms. One is 0 over 0, the other one is infinity over infinity. So the conditions for this rule is both function f of x and g of x, f of x on the numerator, g of x on the denominator must be differentiable. That is, they must have some derivatives in an interval containing the point a, except for x equal to a itself. The limit x approaches c, f dash of c divided by g dash of x must exist. It should be a finite number or another limit that can be evaluated by using L'Hopital rule. Before going to the problem, it is necessary to remember these conditions. E to the power 0 is equal to 1, e to the power infinity is equal to infinity, e to the power minus infinity is equal to 0, ln 1 is equal to 0, ln infinity is equal to infinity, sin 0 equal to 0, cosine 0 equal to 1, sin pi equal to 0, and cosine pi equal to minus 1. Let us move to the problems. Evaluate limit x approaches 0, 1 minus cosine x over x. So what I'm going to do, first you have to substitute the limit value. What is the limit value here? 0. So the given problem becomes 1 minus cosine 0 divided by 0. So we know that cosine 0 is 1. So we have 1 minus 1 over 0. So that will give you 0 by 0. This is an indeterminate form. So to evaluate this form, I have to apply the rule called L'Hopital. As per the rule of L'Hopital, what we have to do, we have to differentiate numerator one time, that is d by dx of the numerator, and we need to differentiate the denominator one time with respect to x, that is d by dx of x. So this will give you limit x approaches 0, derivative of 1 will be 0, derivative of cosine will be minus sine. There is already a minus sign is here, so we'll have sine x. In the denominator, if I differentiate x, that will give you 1. After the differentiation or after the derivative, I have to again substitute the limit value. So this will give you sine 0 by 1. What is sine 0? Is 0. 0 divided by 1. So 0 divided by 1 is again 0. So I have concluded that limit x approaches 0, 1 minus cosine x over x is equal to 0. So 0 is the answer for the problem. Let us move on to question number 2. Evaluate x approaches 1 sin pi x ln x. So first let me substitute x equal to 1 in the function. So that will give you sin pi multiplied 1 divided by ln multiplied 1. So this will give you sin pi over ln 1. In the first slide, I told you sin pi value is 0, ln 1 also 0. That is the natural logarithm of 1 also equal to 0. So that will give you 0 by 0. So again, it is an indeterminate form. So we have to apply L'Hopital rule. So what is L'Hopital rule? We need to differentiate the numerator and differentiate the denominator. That is d by dx of sin pi x divided by d by dx of ln x. Okay, what is derivative of sin pi x? Derivative of sin pi x will give you cosine pi x, and using chain rule, derivative of pi x will give you pi. In the denominator, we have ln x. We know that derivative of ln x will be 1 by x. Then this x will go up. So let me rewrite the equation. Rewrite the function. So that will give you pi x times cosine pi x. Since the derivative is over, now it is a time to replace x value by 1. So that will give you pi times 1 times cosine pi. Again for this x we substitute 1. So this will give you pi multiply 1, pi, cosine pi. So pi times cosine pi. We know that cosine pi is minus 1. So I have pi times minus 1. So that is equal to minus pi. Okay. So the answer for this problem, limit x approaches 1, sin pi x over ln x is equal to minus pi. Let us move on to question number 3. Limit x approaches infinity, e to the power 1 over x minus 1 divided by 1 by x. So in step number 1, let me substitute x value equal to infinity. So that will give you e to the power 1 by infinity minus 1 divided by 1 by infinity. We know that 1 by infinity is 0. So the numerator becomes e to the power 0 minus 1 divided by, again in the denominator I have 1 by infinity, which is 0. E power 0 is 1. So 1 minus 1, the numerator will become 0. We have already 0 in the denominator. So I have ended up with an indeterminate form. So how to solve the problem? By using L'Hopital rule. What is L'Hopital's rule? We have to differentiate numerator separately. We have to differentiate denominator separately. Okay. So here in the numerator we have e to the power 1 over x. So derivative of e to the power 1 over x is 1 over x times, after that by using chain rule we have to differentiate 1 by x. So the derivative of 1 by x will be minus 1 by x power 2. Then if I move to the second term, we have minus 1. So derivative of minus 1 will be 0. Divide by, in the denominator also we have 1 over x. So let me differentiate 1 over x. So that will give you another minus 1 by x power 2. If I cancel these two, we have left with only e power 1 by x. So that means limit x approaches infinity, e to the power 1 over x. Now let me replace this x by the value infinity. We'll have e power 1 by infinity. What is e power 1 by infinity? 1 by infinity is 0. So we will have e to the power 0. What is e power 0? That is equal to 1. So answer for this problem is 1. Let us discuss one more question. Limit x approaches 0, sin x minus x divided by x power 2. So as per step number 1, let me replace x value by 0. So we have sin 0 minus 0 divided by 0 power 2. Sin 0 is 0. 0 minus 0 will give you 0. The denominator also 0. So we have end up with an indeterminate form. So I have to apply L'Hopital rule. So limit x approaches 0. Let me differentiate the numerator one time with respect to x. So in the numerator we have sin x. So derivative of sin x will be cosine x minus the second term we have x. Derivative of x will be 1 divided by, in the denominator we have x power 2. So derivative of x power 2 will be 2x. After differentiation we have to replace x value by 0. So we have cosine 0 minus 1, cosine 0 minus 1 divided by 2 times of 0. What is cosine 0? Cosine 0 is 1. So we'll have 1 minus 1 divided by 0. So that means again I am getting 0 by 0. That means one more time you have an indeterminate form. So again one more time you need to differentiate. Now you have to differentiate this one. So we have limit x approaches 0. The derivative of cosine x will be minus sin x. The derivative of minus 1 will be 0. The denominator we have 2x. Derivative of 2x will be 2. Now I have to replace the limit value. Here the limit value is 0. So we'll have minus sin 0, or I can say sin 0 by 2. We know that sin 0 equal to 0. So we have 0 divided by 2. 0 divided by any number will be 0. So I say that the answer for the problem, limit x approaches 0, sin x minus x divided by x squared is equal to 0. So please remember, sometimes we have to apply L'Hopital rule only one time for the problem. Sometimes more than one times also we can apply. So whenever you have 0 by 0, just keep in mind you need to differentiate numerator one time. You need to differentiate denominator one time. In this problem, two times we have a 0 by 0 form. So I have to differentiate two times. This is my first time and this is my second time. So we have to differentiate two times numerator and denominator separately to get the final answer. Let us see one more example. This for the previous four models, we have discussed this model 0 by 0 case. Now in this question, we are going to talk about infinity by infinity model. That is infinity in the numerator, infinity in the denominator. This question, limit x approaches infinity, 5x power 2 minus 3x upon 7x power 2 plus 1 by using L'Hopital's rule. So as usual, first step, you have to replace x value by infinity. So we have 5 times infinity power 2 minus 3 times infinity divided by 7 infinity power 2 plus 1. So we easily observe that the numerator will become infinity, the denominator also will become infinity. So now we are going to have a form 0, not 0 by 0, we have a form infinity over infinity. But anyway, either 0 by 0 or infinity by infinity, we need to apply L'Hopital's rule. So what is L'Hopital's rule? I have to differentiate the function. That is, I have to differentiate the numerator rational function separately, the denominator of the rational function separately. So let us differentiate the numerator first. We have 5x power 2 minus 3x. So derivative of 5x power 2 equal to 10x minus derivative of 3x is equal to 3 divided by derivative of the denominator 7x power 2 will be 14x and derivative of the next term in the denominator 1, that will be 0. So we have 10x minus 3 upon 14x. Once again, if I change the limit value as infinity, we have 10 times infinity minus 3 divided by 14 times infinity. So 10 times infinity is infinity, infinity minus 3 is infinity, divide by 14 times infinity also infinity. So that means again I have an indeterminate form, infinity over infinity. So what I do, we have to differentiate the previous function one more time with respect to x. So here we have 10x, so derivative of 10x will be 10, derivative of minus 3 will be 0, derivative of the denominator 14x will give you 14. So I have 14, 10 over 14. If you see here, there is no x to substitute, so you have only 10 by 14. It is a constant function, so just cancel 10 and 14, that will give you 5 over 7. So answer for this question is 5 over 7. If the same problem given in the exam and they are not asking you to apply L'Hopital's rule, then you can use your previous method. In the other videos, we have learned that whenever x approaches infinity, what I do, we have to look for the highest degree in the numerator and you have to look for the highest denominator degree. So here the highest numerator degree is 2. What about the denominator? The denominator also, the highest degree will be 2. Okay, so the numerator and denominator both have same degree. Then what I do, the answer is the coefficient or the number before the highest degree in the numerator divided by the number or the coefficient before the denominator degree. So here the numerator, the coefficient is 5. In the down, the denominator, the coefficient is 7. So I can say the answer for the problem is 5 by 7. So two ways you can use, you can solve this problem. First method is L'Hopital's rule. Second method, by direct applying the value of infinity in the numerator and denominator. So depends upon the question asked in the exam, you need to solve the problems accordingly, either first rule or second rule. As usual, we have given you some questions. Try yourself. The answers also is here. You can check your answers. See you in the next video.